did this, which then we said that was equal to, I'm going downhill, aren't I? But I'm writing even. I don't know what the deal is. Okay, what else did we say yesterday? Does anybody remember? Did we say negative pi over, okay, time out. We're going to try.
Sorry, just want to point that out that it's not recording.
Thank you for telling me. I forgot.
Should have waited like 20 minutes.
Sorry, you forgot to turn it back on, so we're on tangent now. All right? Tangent is also negative pi over 2 is less than or equal to x, which is less than or equal to pi over 2. Now, when you just graphed tangent and cotangent, how far down on the graph did tangent go? Anybody remember? Didn't we put an arrow at the bottom that said it went down forever? And how far up did it go? Forever. So for the y value on tangent, it is from negative infinity, and it can't be, I don't know how to get out of this, so I guess I'll do it again. Do you know how to get out?
No.
Cannon can just watch this, I guess. Okay. Can't be equal to infinity. So the y value from the graphs goes down to infinity and up to positive infinity, right? So the only thing we changed on tangent is we are now from negative infinity to infinity on y, right? So I can use any number to do inverse tangent on. I couldn't use any number for sine, could I? What's the third one? Which one I haven't not done yet?
Cosine.
Cosine. And by the way, isn't this in also quadrant 1 and 4? Positive in quadrant 1, negative in quadrant 4. What?
On the pi over 2, and then on the book it doesn't say equal to.
Because it's undefined, not equal to.
Oh, okay. Gotcha.
But we did equal to because that's where we did our asymptotes.
Okay.
Good call there. Good question. All right. And that's why it doesn't have that.
Okay.
The last one is cosine of x. We did it the same way. X is equal to, do you remember that the negative 1 means inverse cosine or arc cosine?
Yes.
All right.
Is there a difference between inverse sine or arc sine and regular inverse?
Is there a difference between inverse and arc?
Yeah.
No.
Okay. I didn't think so, but
Yeah. For x, it is now between 0 and pi. It is quadrant 1 and 2. Anybody want to venture a guess for the reason? Why is cosine use quadrant 1 and 2 instead of quadrant 1 and 4? Quadrant 1, cosine positive or negative?
Positive.
Positive. Quadrant 4, cosine positive or negative? Positive. So if I use 1 and 4, it doesn't have a negative quadrant. And we've got to allow it to be negative somewhere. That's why cosine uses 1 and 2.
so could it all? Why isn't it 1 and 3? Because it's a 3 also negative.
It is. Well, actually, it would be more difficult if it was 1 and 3.
Oh.
But as far as why, this was set years ago, and your calculator is even programmed for this.
Okay.
So Why they chose that, I don't know. All right. So these are the rules that I'm following. Let's do some examples. All right?
What is y between cosines?
Oh, what is y between? What's it between when we graph it? How far down does the cosine graph?
-1.
Negative 1 and 1, isn't it?
Yeah.
Okay. You probably already said this, but why is tangent to infinity instead of big?
Because a tangent graph goes down forever, whereas a sine and cosine, when it gets to 1, it curves and goes back up. All right. Let's do the arctangent of radical 3 over 3. What quadrant is that going to be in? One. For all of them, all three of them. If it's positive, it's always in quadrant 1.
Okay.
So we don't have to worry about positive, do we? Is this radical 3 over 3 the same thing as 1 over radical 3?
So it's a 30, 60, 90.
They're all either 30, 69 or 45, 45.
Yeah.
Or on an axis. All right, quadrant 1. Tangent is what?
Opposite over adjacent.
So this is 1 and this is radical 3, which means what is my angle? X equals pi over 6. Do we all agree with that?
Yes.
Everybody's okay with that. So what if I switch this around and I said I wanted the arctangent of negative radical 3?
Which means it's negative pi over 3. Right?
They're thinking. What quadrant is it in? 4. So if I draw my triangle, maybe that helps. This is negative radical 3 and this is 1. Right? What is this angle right here? Negative pi over 3. Okay? Well, you were right, but I had some quizzical looking faces looking at me. They weren't sure how you got it, so we needed to. Everybody okay with that? Okay. What if I tell you arc cosine of radical 3 over 2? What quadrant is that in? Quadrant 1? And cosine is adjacent over hypotenuse,
Which makes it a pi over 6.
which makes it pi over 6. You know what's coming next, don't you? What have I not done as an example? What I haven't done is a negative cosine. Should do one, shouldn't we? I think that's a great idea. quadrant am I in? No. What quadrant am I in?
You're in quadrant 2.
I'm in quadrant 2
Oh, is it?
because cosine is 1 or 2, isn't it? So I'm here, aren't I?
Yeah.
What is this angle?
Pi over 4.
No, that angle is positive pi over 4 because that is a reference angle. This angle is pi over 4.
So on cosine, is there never a negative angle?
There is not.
Oh. Okay.
Oh.
Do you agree that that angle has to be pi over 4?
Yeah.
Yes.
So my answer is this angle.
Oh,
Wait.
so 3 pi over 4. Oh, yeah.
My answer is, we always start on the positive x-axis and go to the end of my. So x is,
So could it technically be a negative right here if you go
Yeah.
for like it was 5?
okay, could it technically? It could technically be negative 5 pi over 4. Is that what you're saying? But didn't we say at the beginning cosine had to be between 0 and pi?
Ah, okay.
All
That
these
make sense?
technicalities.
See, we restricted where our answer had to be. Okay? Everybody okay with that? Do we need another negative cosine example? No, you're okay?
One more.
Okay. Just for fun? How about just for fun?
Yeah. For canon.
I'll do one of these and then I'll throw a hard problem at you. What quadrant is that in? Huh? The second. Right? And since it's cosine, this is -1, this is 2. What is my reference angle? The reference angle is the angle inside the triangle.
Pi over 3.
Pi over 3?
Yeah, so the answer would be 2 pi over 3.
This is pi over 3. The answer would be this one, which would be 2 pi over 3. Okay?
Yeah.
Can we finish with a hard problem?
Yes.
Like a real hard problem? Might as well.
Gotta be prepared for the less than.
All right. If sine or cosine is 1, -1, or 0, it has to be on an axis every time. Sine or cosine is -1, 1, or 0. Has to be on an axis. All right? So, I know this is on an axis. I believe that I know x is -1. Do you agree with that?
Yes.
Yeah.
What is r?
1.
1. Correct?
Yep.
Okay. So I said for this one, x is -1, r is 1. That's not y, r.
Couldn't X also be positive one?
No, it's negative. And the r has to be positive.
Oh, you guys are trying to the cosine?
Yeah.
Oh, okay. I thought we were talking
Oh, no, no, no. What is y?
0.
Y has to be 0. Right? So where is this point? Here?
Yeah. So pi.
So pi? Chandler, what's wrong?
Well, couldn't that -1 just be -1 over 1 and your x is -1 and your y is +1 and you would still get -1 for cosine?
You got the -1 already.
Say that again.
I don't really know how to say it.
She's saying like -1 over
But I'm
1.
setting it up as
Okay,
Well, that's
isn't
cosine.
isn't cosine x over r?
yeah.
So x has to be -1, r has to be 1. Does that make more sense if I say it like that? Remember, it's always a fraction. So, here we have 3 times pi. You all agree with that much of it?
Yes.
Yes.
Minus, when is tangent 0? Tell me what tangent is. Tangent is, which is y over x. Correct? So is y equal to 0 and equal to what? Isn't that here? So what is my angle? So -4 times 0.
So if it's
So it's 3 pi.
if any of them are 0, is it always just 0?
No. Well, yeah, for these, yes. Yes. What is this?
3 pi.
3